Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever managed to stay on top of the food chain. Animal super senses. You won't believe what's possible. Hello, and welcome to another installment of Animal Super Senses, the show where animal instincts and perception are the stars. In this episode, we examine how every animal has what could be called the sense of rhythm, the human animal included. To give an obvious example, there's our internal body clock that responds to circadian rhythm. That's the 24-hour day and night cycle. Circadian rhythms are synchronized with what is known as photoperiod. In simple terms, the length of a day. Changes in the amount of available light are detected by mammals in a tiny area of the brain called the SCN. It's like a master clock which responds to the environmental cycle. Some animals, of course, are diurnal, mostly active during the day, while others are nocturnal. They sleep through the day and are busiest after the sun goes down. But there are other rhythms with a longer cycle, often in tune and affected by the seasons. For example, biologists recently identified a photoreceptor cell deep inside the brains of birds, which responds to daylight and nightlight, but also regulates breeding activity according to seasonal changes. Animals synchronize their body clocks for biological purposes, such as reproduction, hibernation, fur color changes, and migration. But exactly what senses are at work to help animals keep in tune with the rhythms of day and night and the changing seasons? The answers coming up in this episode may just surprise you. Did you know that all vertebrate animals, which of course includes human beings, have a special organ, the pineal gland, also known as the third eye, which detects daily changes in the amount of light? In human beings, the pineal gland is located in the center of the brain. But in birds, reptiles, and fish, it is located on the forehead, just underneath the skin. For workaday diurnal animals, the light-sensitive pineal gland releases more melatonin during the night than by day. This helps animals set their body clocks, letting them know when to be active and when to go to sleep. As mentioned, humans have a pineal gland, and this so-called third eye has long been attributed with mystical powers since ancient times. Whatever its spiritual properties, the pineal gland seems to help animals adhere to a 24-hour rhythm and regulate their sleeping and waking cycles. Some lizards, frogs, lampreys, and species of fish literally do have a third eye, known as the parietal eye. The tuatara is a reptilian survivor of the dinosaur age and is found only in New Zealand. In mammals, the pineal gland is buried deeper inside the forehead, meaning that it cannot receive light directly. So how does it sense changes between day and night? Recent research has found that the pineal gland is directly linked to the retina in eyes. In diurnal mammals, and again it includes us, the melatonin hormone makes us sleepy. Scientists have recently shown that in nocturnal animals, the pineal gland still secretes melatonin, even during darkness, during the period when night creatures become the most active. So clearly, melatonin is not the universal sleeping pill. In some species, it may have the opposite effect. Incidentally, do you know how much sleep the average adult requires? That's right, only 5 more minutes. Excuse the levity. Of course, the whole cycle of life is in so many ways dependent on timing. The changing seasons has an impact on reproductive cycles in many species. Animals like these Rocky Mountain Bighorn Sheep, found in high places from British Columbia to Arizona, live their entire lives in sync with the changing of the seasons. Changes in temperature and the lengthening or shortening of days, these are keenly felt at high altitudes. The timing of the mating season becomes vitally important in harsh climates. Mating occurs at a particular time so that the young may be born when the weather is at its mildest and resources are most abundant. Staying in Arizona, where these pronghorn antelope are most definitely seasonal breeders. Mating season begins with a head-butting contest between males, as they compete for mating rights and access to females. Bucks separate from others in August and begin hanging around with the does. Male pronghorns grunt and snort, pushing and fighting the other bucks to gain the attention of females. They rub their antlers on trees and bushes, marking areas with their scent. It's an impressive display, but it won't be totally unfamiliar to anyone who watches so-called reality television dating shows. This sense of timing is found throughout the animal realm in such phenomenon as hibernation, fur color changes, or migration. We'll take a look at all of these in due course, but first up, let's see if we can both get our lips and your heads around a state of suspended development called embryonic diapause. It's just what it sounds like. Embryonic diapause, that is. The embryo takes a pause, meaning the embryo does not immediately implant in the uterus, but is maintained in the state of dormancy. By far, the most famous case of this state of arrested development takes place in the outbacks of Australia. This is a reproductive strategy, so kangaroo moms can time the birth of their young in order to avoid going into labor during unfavorable environmental conditions, such as droughts. When the time is right, the embryo is reactivated. The little joey kangaroo is born and then crawls into its mother's pouch. This phenomenon occurs in a number of marsupial species, but is especially prevalent among kangaroos and wallabies. This is also known as delayed implantation. It's something common to rodents, bears, weasels, and badgers too. The arrested development of a joey almost pales in comparison with how some animals are able to shut down everything but vital signs during that state of suspended animation we know as hibernation. And the world's super hibernator is undoubtedly this fearsome-looking predator, the black bear. Also known as the American black bear, though they can be found in large numbers across the border in Canada as well. American or Canadian, it doesn't matter. In any case, the black bear hibernates 5 to 7 months of the year, during which time it does not eat, drink, urinate, or defecate. During this period, they completely throw all their other circadian rhythms out the window. As they move from summer to autumn, black bears, and indeed bears in general, begin feeding even more than usual. Males and females will gorge themselves on an average of 30,000 calories a day. We don't advise that you try this at home. This conspicuous consumption is all for a reason. It creates a layer of fat which will act as insulation and kind of a metabolic reservoir for their time in super hibernation. Now, chipmunks are of course hibernators too, so let's compare what they get up to with the habits of the black bear. When the chipmunk goes into a deep sleep, its body temperature can drop by more than 6.6 degrees Celsius. The upshot is that the chipmunk must wake up every few days and feed like nobody's business. The metabolism of a black bear, on the other paw, will slow to where they are taking just 1 or 2 breaths per minute, and their hearts beat 8 to 12 times per minute. But this is not a competition. And there's no doubt that many small mammals, such as chipmunks but also woodchucks and ground squirrels, are some world-class hibernators. The hibernation habits of the Arctic ground squirrel are surely worthy of note. A year-round resident of the Arctic tundra, this ground squirrel has a hibernation period of up to 7 to 8 months. During its deep sleep, the Arctic ground squirrel's core body temperature drops just below freezing. Once every 2 to 3 weeks or so, it shivers and shakes without waking for more than a dozen hours at a time to reheat its body. Another way in which animals have the sense to register changes in seasons is by changing into their winter wardrobes. The Arctic fox is a classic case in point. Life can be difficult for this elegant-looking little creature, but the Arctic fox makes the best of its lot, preying on whatever creatures it can find for survival, including lemons and voles, and perhaps, to make life on the tundra a little less solitary of a journey, the Arctic fox is a monogamous creature and mates for life. They're also relatively involved parents, with mother and father helping to raise the average of 5 to 8 cubs. Be that as it may, let's get back to the Arctic fox's fashion sense. During the short Arctic summer, its fur is a brown color. As winter sets in, the fur thickens and turns white, thicker for obvious reasons. White so that the creature's camouflage matches the season, and that of course means white as snow. Animals' body clocks can last longer than a day, or a season, or even a whole year. To illustrate, we leave the frozen tundra of the Arctic behind and travel to the deciduous forests of the eastern United States, the principal habitat of the periodical cicadas, also known as magicicadas. Cicadas spend a lot of time underground. In fact, the vast majority of their lives. For a period of either 13 or 17 years, both prime numbers you will note, cicadas stay underfoot, feeding on the roots of deciduous trees, and yet, slowly, ever so slowly over this time, they develop and mature. Then, finally, for a bit of few glorious weeks, when the almost adult cicadas are at the so-called nymph stage, they emerge from the ground in large numbers. They shed their skins one last time, and after a few days, their exoskeletons harden completely. Then they take to the skies, singing the familiar cicada mating call to find a mate. The question is, after every 13 or 17 years, how do they know when to come out in such precise intervals? Recent research thinks they may be keeping track of the sap cycles in trees, but still, no one knows for sure. One thing we haven't really touched on in our examination of animal timing is the effect of the moon on animals. For the lunar cycle governs the timing of natural events as much as the sun. A long way from cicadas, at the edge of the ocean in this case, the coral reefs around the Gold Coast of Australia. We can see clearly how life is affected by the lunar cycle, especially in underwater life. For just 1 week of every year, in spring, after a full moon, millions of corals will release their eggs and sperm in a symphony of reproductive activity. This spectacular example of group sex, which is what it is if you think about it, has long been a source of fascination. But up until less than a decade ago, it was a mystery how these seemingly primitive beings, which somehow get through life without brains or eyes, synchronize their annual mass spawning. But in 2007, scientists were able to isolate an ancient gene in the corals, which is capable of detecting moonlight. On Animal Super Senses, every episode serves to demonstrate that while we like to think of ourselves at the top of the food chain, when we look at our senses compared to the phenomenal abilities of other animals, we are just fumbling in the dark with earmuffs on. See you next time on Animal Super Senses.